What if I told you there's a monster in our solar system? Massive, violent, with storms the size of Earth. And without it, you might not even exist? That monster is Jupiter, the biggest planet we have. A gas giant more than 1,000 times the size of Earth, with a gravitational pull so intense, it acts like an invisible shield between us and cosmic chaos. For billions of years, Jupiter has defended Earth from countless space threats. Asteroids, comets, rogue debris, many of them diverted or absorbed by this giant. Sounds like science fiction? It's not. It's real, and it's happened. More than once. In this video, you'll discover why Jupiter might be our greatest protector, how it was born, and what could happen to Earth if it suddenly wasn't there anymore. You're about to meet the most powerful and most underrated force in our solar system. Jupiter was born in chaos. About 4.6 billion years ago, the solar system was nothing but a swirling cloud of dust, gas, and ice spinning around a newborn sun. It was violent. Explosions, collisions, gravitational chaos. Nothing was calm. And in the middle of this storm, Jupiter became the first planet to form. That detail changes everything. Being first means Jupiter, formed from the richest, most pristine materials in the solar nebula, hydrogen and helium, that allowed it to grow fast, unbelievably fast. Within just a few million years, Jupiter had already become a cosmic giant. Its gravity was insane. It pulled in everything: rocks, gas, comets, debris. Sometimes it consumed them. Other times, it threw them out of the solar system entirely. Some scientists believe that without Jupiter, rocky planets like Earth may never have formed. Jupiter cleared out the cosmic junk, allowing smaller planets to develop in peace. But here's the twist. Jupiter almost destroyed everything. In its early days, Jupiter began migrating inward, toward the Sun. If that had continued, it would have swept away Mercury, Venus, and Earth. But then came Saturn. Saturn's gravity caught Jupiter in a kind of orbital dance. Together, the two giants locked into a gravitational resonance that stopped their migration. That cosmic braking system saved us. Thanks to that, Jupiter ended up where it is now, about 778 million kilometers from the Sun, close enough to protect the inner solar system, far enough to avoid chaos, and this position is perfect. Jupiter sits like a bodyguard between Earth and the danger zones. The asteroid belt between Mars and Jupiter is filled with rocky debris that could easily be kicked toward Earth, if not for Jupiter's gravitational influence. Even farther out is the Oort cloud, a frozen sea of dormant comets. When one of them starts moving inward, Jupiter is often the first and last an obstacle in its path. Its gravity pulls many of them in, like it did in 1994 with comet Shoemaker Levy 9. That impact left huge scars on Jupiter's surface. If it had hit Earth, we wouldn't be here to talk about it. So no, Jupiter's current position is not random. It's the result of a delicate cosmic choreography, and it's exactly where it needs to be to protect us. Jupiter is more than just the biggest planet in the solar system. It's a silent warrior, constantly fighting invisible battles to protect us. But how exactly does this gas giant deflect, capture, or even destroy asteroids and comets? It all starts with gravity. Jupiter is more than twice as massive as all the other planets combined. That gives it a gravitational pull so intense, it acts like a mobile force field. Anything that passes nearby, whether a rogue asteroid or an icy comet, feels its influence, but it's not just raw gravity. The key lies in how Jupiter moves and interacts with these objects. Picture a comet traveling for millions of years from the Oort cloud, heading toward the inner solar system. As it gets close, it enters Jupiter's hill sphere, a massive zone of gravitational influence. From that moment, anything can happen. Most objects are simply deflected. Jupiter acts like a cosmic bouncer. As the object gets too close, it's pushed onto a different path, away from Earth. Without Jupiter, simulations show Earth would face far more frequent and devastating impacts. Sometimes Jupiter doesn't just deflect, it captures. It traps objects in stable orbits. This is how many of Jupiter's companions, like the Trojan asteroids, came to be. They were pulled in, and now orbit with Jupiter in gravitational safe zones called Lagrange points. Thousands of potential Earth killers became harmless orbital hitchhikers, and sometimes Jupiter takes the hit. In 1994, comet Shoemaker-Levy 9 was torn apart by Jupiter's gravity before slamming into its atmosphere. The explosions left scars bigger than Earth. That impact was visible through Earth-based telescopes, and it would have been catastrophic if it hit us. More impacts followed. In 2009, 2012, 2016, and 2021, unidentified objects struck Jupiter. Each time, Jupiter took the blow. But Jupiter can also be dangerous. If a comet passes at just the right angle, Jupiter's gravity can accelerate it, slinging it forward like a gravitational catapult. Instead of protecting us, it can send a high-speed object directly toward Earth. So yes, Jupiter is a shield, but even shields can deflect the blade in the wrong direction. That's why astronomers constantly monitor its interactions. Every simulation tells the same story. Without Jupiter, we might not be here. Imagine a solar system where Jupiter never existed. Nothing occupying the orbit between Mars and Saturn. No massive presence to shape the early chaos of planetary formation. It may sound like a minor detail, but that absence would change everything. Absolutely everything. Without Jupiter, the asteroid belt would have taken a very different path. Instead of a relatively stable region, it would become a chaotic battlefield. Asteroids would drift without guidance, colliding with each other and being flung into the inner solar system. In this scenario, Earth becomes a constant target, like standing in the middle of a cosmic storm. Impacts like the one that wiped out the dinosaurs could repeat every few million years, erasing entire ecosystems before intelligent life ever had a chance to evolve. The time nature would need to build something as complex as a human brain would, be crushed under a cycle of endless extinctions. But we might not even need to go that far, because without Jupiter, Earth's own story might never have begun. During the early solar system, the late heavy bombardment was partially mitigated by Jupiter's gravity. It absorbed and deflected a huge number of objects from the outer regions. Without it, the barrage of impacts on the inner system might have been so intense that rocky planets like Earth could have been destroyed before ever fully forming. In place of a blue planet, we'd have rubble, or a hellish world of lava, thick, toxic atmosphere, no liquid water, no tectonic stability, and no biology. Even if Earth had somehow formed, there's another issue. The long-term stability of planetary orbits depends heavily on Jupiter. Its colossal mass acts as a gravitational regulator, keeping its neighbors in check for billions of years. Without it, the orbits of Saturn, Uranus, Neptune, and even the inner planets could shift into chaos. Over time, those orbital changes could lead to planetary collisions or ejections into deep space. The solar system wouldn't be a precise clock. It would be a wild, unstable machine. There's also the matter of water. Without Jupiter, Earth might never have received enough of it to be habitable. One leading theory suggests much of our water came from comets and asteroids redirected. By Jupiter's influence, it acted like a cosmic delivery service, sending ice to the right places at the right time. Without it, Earth would likely have remained dry. No oceans, no rivers, no clouds, just a cracked, rocky wasteland under a silent sky. And even if we passed all those hurdles, formation, stability, hydration, there's still the looming threat of giant comets from the Oort cloud. These icy bodies, dozens of kilometers wide, travel slowly across vast orbits. Jupiter acts as a shield, capturing or deflecting many before they can reach us. Without it, they'd have a clear path. Every few million years, one might slam into Earth with extinction-level force. The planet would become a stage for endless cycles of destruction and rebirth, constantly reset before life could ever get far. In the end, maybe intelligent life would have never existed. Thought, culture, science, all of it requires time and calm. Billions of years without planetary catastrophe. And that's exactly what Jupiter helped provide. Without it, perhaps there would be no one here asking these questions. Despite its colossal size, Jupiter still hides mysteries that challenge our understanding. Behind that image of a swirling gas giant with colorful bands in constant motion lies a level of complexity we're only beginning to uncover. One of the greatest enigmas is its core. For decades, scientists believed Jupiter had a solid, rocky core formed during the early days of the solar system. But data from the Juno and Galileo missions have turned that idea on its head. The results suggest something far more chaotic: a diffuse, diluted core, possibly blended with the surrounding gas. No clear boundary, no solid ground. It's as if Jupiter's internal structure was shattered, or maybe never fully formed. This uncertain core raises unsettling questions. Did Jupiter collide with another giant planet during its youth? Did a gravitational upheaval rip its structure apart from the inside? The answers remain elusive and fascinating. What we do know is that the pressures deep inside Jupiter are so intense hydrogen, normally a light, harmless gas, gets crushed into a metallic liquid. A vast, invisible ocean of metallic hydrogen that spins rapidly beneath the clouds. That internal movement, combined with the planet's insane rotation speed, less than 10 hours per day, creates a massive dynamo, generating the strongest magnetic field in the solar system. A magnetic shield so powerful it stretches millions of kilometers into space, engulfing entire moons in its grip. And it's deadly. The radiation trapped within that field is intense enough to kill a human in seconds. This is not a place for life. It's a fortress of charged particles spinning endlessly through space. And in the middle of that chaos comes something beautiful: auroras. Jupiter's auroras are the brightest and most powerful in the solar system. But unlike Earth's, which are triggered by solar winds, Jupiter's are also powered by its rapid rotation and the volcanic fury of its moon Io. These auroras are constant, burning at the poles like cosmic eyes, never closing. They aren't just light shows, they're signs of energy, violence, and raw planetary force. Yet perhaps the most haunting fact about Jupiter is that it could have been a star. It has the mass of a giant, but not quite enough to ignite nuclear fusion. Still, it glows. Jupiter emits more energy than it receives from the sun. It's still radiating heat from its formation, as if it never fully cooled down. It's a reminder that the line between planet and star isn't as solid as we'd like to think. Add just a bit more mass, and Jupiter could have lit up as a failed star, a brown dwarf shining faintly in the cold of space. Jupiter, then, isn't just a planet. It's a moving gravitational storm, a magnetic monster, a place where physics bends and logic fades. And for all its might, there's nowhere to land. The deeper you go, the more pressure and heat rise. Any probe would be crushed long before reaching anything close to a surface. It's like trying to land inside an eternal storm, one that hides, deep in its heart, a story we're still trying to read. Jupiter is a world of extremes, mysteries, and raw power, and we've only just begun to uncover its secrets. If you want to dive deeper into the giants of our solar system, don't forget to like, subscribe, and hit the notification bell. The journey is just getting started.